Yeah. Hi guys, a very good evening everyone. Very good evening everyone. Good evening Avinash. Good evening Just Lil Info. Good evening and welcome once again to the Home Institute. Good evening everyone. Good evening Avinash. Good evening Just Lil Info. Good evening and yes, so looks that audio and video is fine. Okay. So as in the marathon we discussed yesterday, for the continuation, further in the continuation of the marathon, okay, let's have some more practice around control system and specifically only for MSQ questions. So we were discussing, and yes, I told you mostly I'll implement, and yes, here it is. Okay, the MSQ, the dedicated MSQ practice session from the subject of control system, miscellaneous topics, miscellaneous chapters. Okay, good evening Dinesh, good evening Arvind, good evening Sajin, very good evening all. Okay, so come on, let everybody quickly connect. Let us see, is the enthusiasm same as the marathon? Good evening Murli. Good evening Dinesh, good evening Arvind, good evening Sajin, very good evening all. Okay, so let's get started then. Students will keep joining. Yes. So, the MSQ question practice on the control system. Let's get moving ahead. So, mega marathons have started yesterday, as you know, 13th January. Yesterday, we had the non-stop 8.5 hours non-stop revision marathon session of control system. And now, tomorrow, okay, as I already told you, okay, now tomorrow, that is Wednesday, 15th January at 11 a.m. The next mega marathon will be live for you. That is from electromagnetic fields, EMF, to be taken by Hemant sir. Yesterday also I told you. Okay, and this is going to be live tomorrow at 11 a.m. This is going to be live tomorrow at 11 a.m. on the same YouTube channel. So yes, guys, if you are not yet subscribed, do not forget to subscribe so that you are again updated about every activity happening. Okay, so this is the next mega marathon that is on the EMF, and let's get moving ahead. Let's get moving ahead. And very, very good evening, all. Guys, okay, so on the next Sunday, that is actually the coming Sunday, 19th of January, the Om Institute brings to you an online scholarship test. Yes, guys, if you or any of your friends, juniors are interested to enroll for online live courses of Om Institute, okay, any of the online courses, live or recorded, okay, for GATE 26 and GATE 27, okay, the Om brings you online scholarship test where the top 3 performers will be getting a flat 100% scholarship, and based on your performance, you get, decent scholarships. So prove yourself, earn your respect, earn your, scholarships. And this test is on 19 January, as I mentioned, from 6:30 p.m. Good evening, Rakesh Ranjan. And, if you're looking for AE courses, the offline AE course, okay, the next AE offline course for Telangana and as well as AP, Transco and Discoms examination, okay, starts on 23rd of January. Okay, that is at our Hyderabad Center offline batch, and for any details you can contact 9515694053. And this is the question number 1 for the day. This is the question number 1 for the day. Now let's get started with the questions. Let's get started with the question. Okay, all the questions are MSQs. Okay, I'm not mentioning along with every question because today each and every question is MSQ only, multiple select question. Okay, where one or more than one option can be correct. One or more than one option can be correct. Okay, so let us get started with the first one. For the signal flow graph of a system, which of the following is or are correct? Okay, so the number of forward paths, the number of loops, and the gain C by R. These are the different parameters that are discussed in the options. Okay, so let us see one by one what are the different number of forward paths. Okay, the different number of forward paths, one of them, one of them is quickly the horizontal one. Okay, the horizontal path from input to output, any path from input to the output, you will only you'll only travel in the direction of arrows. Okay, so any path from input to output is a forward path. Next, to this one branch, to this unit gain branch, there is an alternate. To this also there is an alternate. Okay, so let me choose the first alternate and second one is horizontal. Similarly, you can go this way also. Okay, these are two more. Rather, I can choose both the alternates only. So this is also the next possibility. This is the fourth one. This is the fourth one, right? Avinash says fourth. Only four. Only four. I can travel through this entire one branch. This gives me fifth one. This gives me a fifth one also, Avinash, right? Okay. So because that's also in the forward direction only. That's also in the forward direction only. So the number of forward paths are 5 actually. The number of forward paths are 5 actually. Okay, now let's see the other parameters. Loops. Okay, how many loops? Now see, all these branches are in forward direction, so they will not contribute, okay, in the feedback gain. Okay, so because this is also forward, the loop would be something like this. Okay, if this was available. Okay, no. So, all of these are contributing to forward. So, loop means only there are three loops and they are the self loops only. Okay, this is going to be L1, L2 and L3. 3 loops and all are self loops. 3 loops and all of them are self loops, correct? 3 loops and all of them are self loops. Okay, so the number of loops 3, correct. Okay, now the final C by R. For C by R, I need the path factors also. Path factors also. One by one, keep looking. One by one. Now, how do you calculate any path factor? Or first, let me write down graph determinant actually. Okay, first let me write down the graph determinant here. Okay, this is L1, L2, L3. Okay, for the graph determinant, I need the loops only, na? 1 minus sum of loop gains. Now, all are non-touching to each other. Okay, so there are 3 non-touching pairs also, L1, L2. Okay, L1, L3 is also non-touching and L2, L3 are also non-touching. Okay, so plus the summation of product of all non-touching loop pairs. Is there a triplet also? Yes, L1, L2, L3 all are non-touching to each other. So there is a triplet and then alternate plus minus. Minus, okay, the products of the triplet term. So there is a triplet L1, L2, L3. This is how you are going to calculate the entire graph determinant. Okay, and hence this delta will be 1 minus. What are the loop gains? Is minus 1, minus 1, minus 1. Okay, so minus 1 into 1, 1. So these product terms will be 1, 1, 1. And minus L1, L2, L3. So minus 1, minus 1, minus 1 is minus 1. So let me see how much it is total. 1 minus minus plus 3. This is also plus 3 and this is also plus 1. The total delta turns out to be 8. The graph determinant turns out to be 8. Correct? Now path factors. How do we calculate any path factor? Because as per the Mason's gain formula, the C by R is given by P1 del, summation of Pk del K divide by delta. For every forward path, you need to multiply by the respective forward path factor. Okay, so how do we calculate any path factor there? How do we calculate any path factor? See, you remove that particular forward path. Okay, you remove the particular forward path. Suppose I erase P1. Suppose this is my first forward path. Okay, this is my first forward path. Or let me name the forward path in this sequence only. Let us say this is 1, 2, 3, 4, 5. Let's write it in this sequence. Okay, so what is going to be first path factor? Delta 1. So when I erase this forward path, keep looking with me. Path factor is the determinant of the remaining graph. What remaining graph? The remaining graph that is obtained after deleting that particular forward path. Okay, so when I delete it, okay, is there any loop left? Yes, the loop L2 is left. The loop L2 is left. The loop L2 is left. So delta 1 will be 1 minus L2. Okay, that is 1 minus minus 1. Delta 1 will be 2. Okay, now delta 2. Now, let me remove this forward path. Second one is mentioned here. So when I'm going to remove this, keep looking. When you erase this. So when you erase this, actually what happens? All the loops are now open. Okay. These nodes are open means the loops are open. Okay. The loops are open. How, how the remaining graph will be? Something like this. Something like this. Okay. So no loops are closed. Okay, and if a graph does not have any loop, all the loops are open, then how much is the determinant? How much is the determinant? 0. 1 minus 0. Okay, 1 minus sum of loop gains, there are no loops left. So the delta 2 will be 1. Delta 3. Okay, now similarly delta 3. If I erase this entire horizontal path, okay, then also all the 3 loops are open. So delta 3 will be 1. Delta 4 will also be delta 4. Now what is the delta 4? See here. Okay, when I remove this such a forward path. But ultimately, removing this forward path also, L1, L2, L3, all are opens. All will become open. Their node will go away. So they are open means no loop is left. And similarly, the fifth case also, it will be 1 only. Okay, all the path factors are 1 except the delta 1 case. Except the delta 1 case. Right? Acha, whatever the forward path P1, P2, P3, can we write down that also? What is my forward path gain P1? Okay, it is the product of all the branch gain coming. So everything is 1 here. Na? So P1 will be 1. Similarly here also 1 into 1 into 1 into 1. P2 is also 1. P3, 1 into 1 into 1 into 1. 1. P4 is also 1. P5 is also 1. The values are simpler values given here. Okay, so what I need to do, I need to go and substitute here. Summation pk del k divided by delta. Okay, first forward path 1. All forward paths are 1. Only delta 1 is equal to 2. Okay, next deltas are also 1. So 1 into 1, 1 into 1. This is fourth one. This is fifth one. Divided by the value of delta, which is 8. Okay, so total answer 2 plus 4, 6. 6 by 8, 0.75. 0.75. Correct. Yes, Avinash, correct. So the total gain C by R is 0.75. Option number C is correct. Option number A, B, C all correct. Now considering that MSQ answers, 3 options are correct here. Yes, just little info. Option number A, B, C. The 3 options are correct here. Option number A, B, C. The 3 options are correct here. Okay. So let us go to the next question then. Okay, the 3 options are correct and this is the next question for you. A second order system has the transfer function 25 upon s square plus ks plus 25. Select the correct option. Simple question. Okay, so the previous one had some calculations. I can call it as, if it is a GATE question, it should be 2 marks. I'll put it that way. If it is a GATE question, it should be 2 marks. This one, if it is a GATE MSQ question, it will be still 1 mark only. Very basic it is, because you can just take up the denominator, that is the characteristic equation, s square plus ks plus 25 equal to the 0. Okay, and the omega n square is 25. Okay, so omega n will be 5, and then this is your corresponding term 2 zeta omega n. Okay, and that is equal to k. That is equal to k. So omega n is known to me. Omega n is 5. So 2, 5, 10. 10 into zeta is equal to k. Now for k equal to 10, okay, for k equal to 10, system is critically damped. Okay, for k equal to 10, system is critically damped. Definitely yes. Okay, definitely yes. You keep looking the calculation here. Okay, if you take k equal to 10, zeta equal to 1, yes, critically damped. Okay, yesterday I revised all these conditions. Now for k equal to 12, zeta will be greater than 1, 12 by 10. Okay, so it should be over damped. It is over damped, be correct. Third, for k equal to minus 2, okay, zeta will also be negative and system is negatively damped, and we call it as unstable. Negatively damped and unstable, so correct. Fourth, k equal to how much? 5. K is 5, so zeta is less than 1. Positive but less than 1, so it is going to be under damped. Okay, so not over damped. So again ABC, 3 options are correct here. Okay, 3 options are correct here. Yes, correct answer for this, just little info and Avinash again. Okay, 3 options ABC are correct here. Yes, ABC. Next question. Let's move ahead to the next question here. Two linear time invariant systems with the transfer functions G1n as G1s and G2s are given. G1s and G2s are given. They have the unit step responses y1t and y2t respectively. Which of the following statements is or are true? Okay. Yes, Dinesh, ABC correct answer. And see, I know one or two GATE MSQs also I have taken. One or two GATE MSQs also I have included, just to show you the nature of the control systems MSQs that have come up in recent 2-3 years. This is a GATE 2022 2 marks question. Okay, so there are two transfer functions given to you, G1s and G2s. They have the step responses y1 and y2. Okay, now what the options are asking, they have the same percentage overshoot. So we know that percentage overshoot depends only on zeta. They have the same steady state value. We will see that they have the same damped frequency of oscillation, that is omega d, and they have the same 2% settling time. Okay, they have the same 2% settling time. So what are these formulas? Okay, they have the same percentage peak overshoot. The percentage peak overshoot, okay, depends only on zeta. If you want the formula, it was written as e power minus pi cot phi into 100, and cot phi depends, phi means depending only on zeta. E power minus pi zeta upon root 1 minus zeta square. Both the ways I have written the formula for you now. And I hope you have downloaded the yesterday's PDF also from the Telegram. Depends only on zeta. Okay, they have the same damped frequency of oscillation. So what is the formula? Omega d is omega n root 1 minus zeta square. They have the same 2% settling time. So what is that 2% settling time? Okay, if it is under damped, let me first now, okay, whether what is the formula for settling time? We know that it should be under damped or critically damped. Accordingly, 2-3 different cases I have given to you. Okay, so let me start solving it now. Okay, and then I'll talk about the steady state value also. Okay, so first one. Let's talk about the first one. G1s, characteristic equation, or let me take the transfer function only, no problem. 10 upon s square plus s plus 1. 10 upon s square plus s plus 1. Okay, so what is the value of omega n square is 1. So omega n is 1, and what is the zeta? 2 zeta, okay, into omega n is 1, so zeta is 1 by 2. Okay, now coming to the G2s, which is given to me as 10 upon s square plus s root 10 plus 10. Okay, now omega n square is 10 here, so omega n definitely for both of them is different. Omega n is root 10. Okay, and then the 2 zeta omega n is root 10, is root 10. That means zeta is 1 by 2. Okay, same zeta, right? Same zeta. Okay, and both of these zetas are positive and less than 1. Okay, both of these zeta are positive and less than 1 means underdamped response. This also is underdamped. So I can now write down the settling time formula. For underdamped we know, it is 4 by zeta omega n. 4 by zeta omega n. For underdamped we know that it is 4 by zeta omega n. Now which of the options are correct? See, same zeta, okay, that means same overshoot. Okay, but whether zeta into omega n same, no, zeta same, omega n different. Okay, so settling time is definitely different. See now, one by one. Zeta 1 equal to the zeta 2. Okay, that means percentage overshoot will be same as the percentage overshoot of the second system, because overshoot depends only on zeta. Okay, so A option is correct. Okay, let us come to the third one, damped frequency of oscillation. Okay. Okay, third option, damped frequency of oscillation. Okay, omega d is omega n root 1 minus zeta square. So see, zeta is common, but omega n is different for both. Omega n1 not equal to the omega n2. So omega d1 is also not equal to omega d2. So they don't have the same damped frequency of oscillation. D option. Okay, the D option, settling time given by the formula 4 by zeta omega n. Again, zeta is same for both, but omega n at least different, na? Omega n1 not equal to omega n2. So settling time, okay, as per the 2% criteria is not same for both. So D also wrong, C also wrong, A correct. Now they have the same steady state value. Okay, normally if you express the transfer function in the standard form, see what is the standard form? Omega n square, or upon s square plus 2 zeta omega n s, the standard second order transfer function, plus omega n square. If you express it in the standard form, then it has the steady state value 1 as we have seen yesterday. But if you express it as k into omega n square, then okay, then it will have the steady state value equal to k times 1. Okay, if you multiply the transfer function by k, the steady state value will also be multiplied by k. Okay, so omega n square here is 1. Okay, this is 10 into omega n square. Okay, so steady state value of this will be 10, or you can find by final value theorem, but I'll directly say it is 10. Okay, and this is omega n square is also 10, so this is 1 into 10, that is 1 into omega n square. And for the second case, steady state value is 1. Okay, so even the steady state value will not be the same. Even the steady state value will not be the same. So only option number A. Only, although it is MSQ, but what is MSQ? We have seen multiple select question where they clearly say one or more than one can be correct. Only one correct. That is also acceptable. Even in the, mathematics MSQ class where I was taking GATE mathematics MSQ, I have shown you, some 2-3 cases where they have called it as MSQ question, but only one option correct. So be ready. Don't be puzzled. Even, in your exam, you get only one option correct for MSQ. Don't be puzzled. Okay. MCQ fix one option correct. MSQ, anything can happen. One or more than one correct. One correct, two correct, three correct, or all four correct. Anything can happen. Okay, so yeah. Then I think let's move ahead to the next question. The open loop transfer functions. Yes, Kadiam and Joshna, Dinesh, Lil Info, Murli. Correct answer, all of you, A. Only A. Right. So the open loop transfer functions with unity feedback are given below. Okay, which of the systems are stable? Okay, which of the systems are stable? So see, open loop transfer function normally is GSHS. But what is HS given? Unity feedback. That means the open loop transfer function, what is given here is GS. What is given here is GS. Okay. So one by one, if I start taking the characteristic equation. Characteristic equation means 1 plus GSHS. So 1 plus 2 upon S plus 2 equal to 0. First order system. When you simplify S plus 2 plus 4, S plus 4 equal to 0. Is this going to be stable? For first order and second order, what we discussed yesterday in the Routh-Hurwitz also. For first and second order, if all coefficients are of same sign, then the system is stable. Nothing to wonder. Na? If all coefficients are of the same sign, then the system is stable. Plus, plus, same sign. Or you can directly calculate root. Now, what is the root? Minus 4. Okay, minus 4. Okay, that is LHP, so stable. So A is stable. Which of them are stable? It's a multiple select question again. Okay, let me go to number C option first. So what is the characteristic equation for number C option? It is 1 plus 2 divided by S, S plus 2. 1 plus 2 divided by S, S plus 2 equal to the 0. Okay, so S square plus 2S plus 2 equal to 0. Again, second order system. All coefficients plus. For first and second order, only all coefficients of same sign is the necessary and sufficient condition. All are of same sign. Stable. So C is also stable. Okay, or you can check from, or you can say that zeta is positive, so system is stable. That also you can say. Now coming to the option number B. Now coming to the option number B, what is my characteristic equation? 1 plus GSHS. Okay, that is 1 plus 2 upon S square S plus 2 equal to the 0. Okay, so S cube plus 2S square plus 2 equal to 0. Now you see here. Now you see here the catch is okay. Now you see here the catch is S power term missing. Okay, if it is missing, that means it has 0 coefficient. All coefficients strictly of the same sign. Okay, all coefficients strictly of the same sign. All coefficients strictly of the same sign is required. Okay, so what happens if a S power term is missing? What will I say? here a s power 1 term missing, and if a s power 1 term is missing, what will I say? That necessary condition fails. The necessary condition itself fails. System cannot be stable. System cannot be stable. So B is not in our list. B is not in our list. Okay. B is not in our list. Okay. See, Avinash, there are two poles of open loop transfer function. Okay. So that is not, I think, the correct way to finally conclude. Okay. There are two poles at origin, but of the open loop transfer function, and we need to comment on the stability of closed loop transfer function. Okay. Right. So take care of that. Okay. And then characteristic equation for the fourth option. Okay. 1 plus twice of s plus 1 upon s plus 2, s plus 3 equal to 0. Solving this, I should be getting s cube plus 2 plus 3, 5 s square plus 2 into 3, 6s, then plus 2s plus 2 equal to 0. Okay, so overall s cube plus 5s square plus 8s plus 2 equal to 0. All coefficients are of the same sign? All coefficients are of the same sign? Yes. But this is higher order. Same sign. That means what will I say here? Only necessary condition is met. Only necessary condition is true. Okay, but whether the system is stable or not, for higher order system, we need the sufficient condition in the form of Routh-Hurwitz. In the form of Routh-Hurwitz or the cubic shortcut. What is the cubic shortcut? S cube plus 5s square plus 8s plus 2 equal to 0. Okay, okay. And what is our sufficient condition? For sufficient condition, we go to the RH criteria. We go to the RH criteria, isn't it? What will I say here is, okay, this is a cubic equation. So we can apply the cubic shortcut. What is that cubic shortcut? What is that cubic shortcut? Just calculate the product of inner and the outer terms. Just calculate the product of the inner terms and the outer terms. See, just for once I will repeat. Okay, if it is as cube, what is that cubic shortcut? As cube plus bs square plus cs plus d equal to 0. Okay, so alternate terms are AC here and here it is BD. ABCD, of course, all positive as per the necessary conditions. So, of course, what I next need is BC minus AD positive. This is my Routh-Hurwitz. This is my Routh-Hurwitz. So, what I also need is BC minus AD. B is positive only. BC minus AD should be positive for stability. Okay, for stability. So, is it correct here? Okay, what is the BC here? Yes, it is 5 into 8. And what is the AD here is 1 into 2, inner and outer. Okay, so BC greater than the AD, system is stable. Okay, so remember, for stability, BC should be greater than the AD, inner greater than outer. If they are equal, marginally stable, okay. BC greater than AD, stable. BC equal to AD, marginally stable. BC less than the AD, sign changes will come to unstable. This is the cubic shortcut. From Routh-Hurwitz only, but this we can take it as the cubic shortcut, correct? So, yes, one, yes. So, D is also the correct one. Okay, so option which are stable, A was stable, C was stable, D is stable, except B. So, ACD is the correct answer here. ACD. And for B, you don't have to apply RH because necessary condition fails. And if the necessary condition fails, then no need for the confirmation from RH. We can say that system cannot be stable if the necessary condition fails. What is that necessary condition? All the coefficients must be of same sign, strictly same sign. If all positive means positive, not even 0. S power 1 term missing means its coefficient is 0. That's what I would say, correct? Next question. Next question here, ready for you. Given the characteristic equation, s power 5 plus 2s power 4 plus 24s cube plus 48s square minus 25s minus 50 equal to 0. Okay, fifth order equation. The number of roots in the right half is 0, right half is 1. The number of roots on imaginary axis is 2. The number of roots in the left half of S plane is 3. Which of the option is correct? Something similar to this I have solved in the yesterday's marathon also. Please complete this quickly, guys. Please complete this one quickly. Okay. Let us check the next answer then. Okay. Fine. So let us form the Routh-Hurwitz first of all, fifth order equation, and let us see what case of Routh is coming up here. Starting with the first two rows, s power 5 and s power 4. Okay, s power 5 coefficients 1 and then 24 and minus 25. And then alternate coefficients s power 4, 2 and 48 and minus 50. 2 and 48 and minus 50. So s power 3. See dear, if they are asking about, suppose if they only want the comments on stability, what will you say? If they only want the comments on stability, you can directly say that all coefficients are not of the same sign, system cannot be stable, necessary condition fails. But I need here actually quantity of roots in the LHP or RHP. So I will go to the Routh-Hurwitz. I'll have to solve the Routh-Hurwitz. So now s cube, 2 into 24, 48 minus 48, 0. 2 into minus 25 is minus 50, again minus of minus 50, 0. Last element of a row always 0. So yes, what do you get? Okay, this is the important case of RH, as I told you, row of 0. And whenever there is a ROZ, we form auxiliary equation by the row above the row of zeros. We form the auxiliary equation by the row above the row of zeros. 2s raised to the power 4 plus 48s square minus 50. 2s power 4 plus 48s square minus 50 equal to 0. And let me differentiate this. Okay, so 4 to 8s cube plus 48 to 96. Sorry, correct. 96s equal to 0. Correct. So what is the modified s power 3 row? From the auxiliary equation, we write down the modified s power 3 row. Okay, what are the coefficients of s power 3 now? That is obtained from the derivative equation, 8 and 96 and the 0. 8 and the 96 and the 0. Now continue with the Routh-Hurwitz in the similar manner. So now s square row will be required. Okay, this is now eliminated. Don't use the coefficients here. This is replaced. So 8 into 48 minus 2. If you want, you can take 8 common, but let's keep solving. 8 into 48 by 8 anyways will be cancelled. Okay, so 48 minus this one. So 48 minus 24. Correct, na? 2 into 96 by 8, 12. So it is going to be 24. 8 into minus 50 by 8. This is minus 50 and this is 0. S power 1. Okay, this is 24 into 96 by 24. How much will be left? 96 and minus plus 50 into 8 by 24. Okay, so this will be still plus only. Cancelled as 3. How much is the final answer? Let me write down actually. Yeah, so 112.67 positive. 112.67. This is going to be 0 because the top column is 0, last element always 0, coming to the s power 0, x into minus 50 by x. So minus 50, yes, we encounter a sign change at the end. We also encounter a sign change at the end, right? That is correct. Yeah. Now, the shortcut, whenever there is an auxiliary equation, no need to solve the auxiliary equation. I told you, don't have to spend the time on solving the auxiliary equation. You have to come up directly by the shortcut table. Yesterday's marathon, if you missed it, you can watch it. All these cases were revised and discussed with the question. On one side of the table, we write down auxiliary equation. On one side of the table, we write down characteristic equation. And first, we write down order of both. The order of auxiliary equation is 4th order and overall characteristic equation is 5th order. Characteristic equation starts with s power 5. Okay. For auxiliary equation, always the number of LHP and RHP roots are same. Okay. For auxiliary equation, the number of LHP and RHP roots are same and equal to what? Equal to number of sign changes below AE, below the auxiliary equation. Okay. So in this part, how many sign changes? One sign change. In this part, there is one sign change. Okay. So in this part, we have the one sign change. We have the one sign change. So L and R are equal and equal to 1. So how many on j omega? Because if there is any j omega root, that is because of auxiliary equation only. Okay. So auxiliary equation is 4th order. One of the root goes to the LHP, one goes to the RHP. 1 goes to the RHP. How many left? 2. Now for characteristic equation, how many RHP roots? Sequences, first write down R, then J omega and then L. R means the total number of sign changes in the first column. The total number of sign changes overall from the top to the bottom is also only one sign change. This is also only one sign change. So R is 1. Okay, R is 1. J omega roots are 2 and L is equal to then 5 minus 1 on the RHP, 2 on the J omega. So LHP roots will be 3 actually. 5 minus 3, the LHP roots will be 2. Okay. And because there are RHP roots, the system is unstable. Now anyways, let's come and conclude our options. Okay, number of roots on the RHP 0 or 1? 1. Option number B, A, wrong. Number of roots on imaginary axis 2? Correct. There is a pair. And number of roots in the left half then is 2. So D is wrong. B and C. Yes, B and C correct answer. Right, Joshna, correct answer B and C. The final correct answer is B and C. The final correct answer is B and C. Okay, the final correct answer is B and C. Okay, fine. Next one. Consider the Bode plot of a minimum phase unity feedback system shown in the figure. Which of the following is or are true? Which of the following is or are true? Okay, a question on Bode plot of a minimum phase unity feedback system is shown in the figure. Which of the following is or are true? The steady state error corresponding to the ramp input is 0.25. Okay, the gain crossover frequency is 1.4. The final phase of the system is minus 180 degree. A velocity error coefficient is 2. The velocity error coefficient is 2. Let's check this. The steady state error corresponding to ramp input. Now, steady state error. See, if you look into the initial slope, first of all, if you look into the initial slope, it is initial slope of the Bode plot is minus 20 n if there are poles at origin. It is given as minus 20. So that means n equal to 1. What is this n? This is the one pole at origin. Okay, and because the system is mentioned to be unity feedback. Okay, so what is the open loop transfer function? Open loop transfer function GSHS is just GS. It is mentioned it is unity feedback system. So GSHS is only GS. That means this is one pole of GS at origin and the number of poles of GS at origin is type 1. Correct, na? Number of poles of GS at origin is known as the type of the system. Type is defined for unity feedback. We discussed the error analysis also yesterday in the marathon session. Okay, it is type 1. Okay, and for type 1 steady state error, if they ask for step, 0. If they ask for ramp, we know that type 1 will go with ramp. For ramp, we will get some finite non-zero answer given by 1 upon kV. If they ask it for parabolic, they can ask it for anything. For parabolic, it will be infinity. Okay, so we know these straightforward conclusions. So if they ask for step or parabolic, we know the answer. We need not calculate. I think they have asked for ramp. Okay, and steady state error for ramp is 1 upon kV, where kV equal to k, remember always, kV equal to the k of the standard form. And from the Bode plot, we will always write down the standard transfer function. Standard means time constant form. Okay, of the standard form, the time constant form. Okay, let us see what is the value of k from the Bode plot. How do you calculate the value of k from the Bode plot? How can you calculate the value of k from the Bode plot? There are two ways to calculate k. There are two ways to calculate the value of k from the Bode plot. Okay, number 1. Method number 1. Initial part formula. Initial part means part up to the first corner frequency. What is the initial part formula of the Bode plot? The initial part formula of the Bode plot is given by minus 20n log omega plus 20 log k. Minus 20n log omega plus 20 log k. The initial part is given by minus 20n log omega plus 20 log k. That is the initial part formula. minus 20 n log omega plus 20 log k, correct? Plus 20 log k. Okay, this is the initial part formula. Now, initial part means up to the first corner frequency. Okay, up to the first corner frequency. Okay, the initial part here is up to omega less than equal to omega 1, the first corner frequency. Okay, so what we can use, see what is given to me at 0.1, at frequency 0.1, magnitude is 32. Use omega equal to 0.1 and magnitude is given as 32. N is already highlighted as 1. So 32 is equal to minus 20 log of 0.1 plus 20 log of k. Log of 0.1 will be further minus 1, so minus plus 20 and then plus 20 log k. Okay, so 12 by 20 log k is turning out to be 12. You solve it, k will be roughly equal to the 4. K will be roughly equal to the 4. Okay, second way to find the k, you should know both the cases. Second way to find the value of k. Again from initial part only, but not by the magnitude formula. Initial part intersects the 0 dB axis at omega equal to k power 1 by n, or k equal to omega raised to the power n. N equal to 1 here. That means k is equal to omega. Which omega? Initial part intersects the 0 dB axis at some frequency omega. Okay. So initial part is up to omega 1. So if this initial part was extended, okay, if I extend this, if there was no slope change, then it can go and cut the 0 dB. Then it will go and cut the 0 dB. Okay, what is this omega equal to? What is this omega equal to? The 0 dB axis. So that you can find using the concept of slope. Okay, what is the slope of this line? Minus 20. The slope of the line minus 20. What is the slope of any line? Change in the y coordinate. Y coordinate here is magnitude. Change in the magnitude. M2 minus M1. Okay, in any time Bode plot formula, you will use the slope as change in y coordinate means change in the magnitude, decibel magnitude. Change in x coordinate, and when you plot the Bode plot, we plotted with respect to log omega. So log omega 2 minus log omega 1. This is the slope formula to be used. So if you use it for the minus 20 line, slope minus 20, how much is the change in magnitude? Okay, 0 minus 32. Okay, and then change in log of frequency. Okay, see, this is log omega. Okay, let me call it as some frequency omega. Let it be log omega minus, what is the first frequency? This is the first point I'm using. The frequency here is log of 0.1. Okay, log of 0.1. Okay, so let us say this is some point A. This is some point A, and this was some point B. Okay, so I have used the section of the line AB. Okay, so from here you can calculate the value of omega. Okay, you can calculate the value of omega, log omega 10 omega. Okay, so you calculate, it should be coming out to be again 4. Let me just cross check. Yes, 40 by 10, 4, correct. Omega approximately 4. And if this omega is equal to 4, k is 4. So by initial part formula or by the 0 dB axis intersection, this is the way to find k. Okay, so what is the value of k? 1 by 4. So what is the value of k is 4. The error is 1 by 4. That is 0.25. Okay, so steady state error to ramp input is 0.25, correct? And velocity error coefficient, okay, kV was equal to 4. So D is wrong. Steady state error A is correct. Final phase and gain crossover frequency. 2 more parameters here. So it's like, multiple things revised about Bode plots from this. Now, what are these 2 parameters? Joshna says answer A and C. Okay, so A is still correct. Let's check B and C. Gain crossover frequency and final phase. Okay, final phase is very simple because what is the final slope here? Just keep looking here. Okay. Okay, what is the final slope? Okay, what is the final slope? Or let me do the slope calculations here. Okay, so let me first find omega g. What is omega g? Let me first complete omega g within this diagram. What is omega g? Gain crossover frequency. Okay, it is the frequency at which, okay, at which the magnitude mod gj omega hj omega equal to 1. Okay, or in decibel. Okay, we know that at omega g, mod gj omega hj omega, the Nyquist plot intersects a unit circle. Okay, in decibel, how much it becomes? In decibel, you have 20 log of the magnitude, magnitude 1 and log 1 is 0. So what is omega g? It is the frequency at which the magnitude becomes 0 dB. So where does the magnitude, actual magnitude becomes 0 dB? Where does the actual magnitude become 0 dB? Let me highlight here. This is omega g. This is the actual magnitude plot. Okay, where the magnitude becomes 0 dB at this frequency. This is omega g. Okay, at this frequency, which is omega g. So again, going by the slope concept. Okay, again going by the slope concept here. This is omega g. So now which line to be used? This was named as B already. So let me name this as some point C. Okay, so use the line CB now. Okay, sorry, C and D, not DB. B is not relevant here. Okay, let's take these 2 points. Okay, that is the CD, C and D. Okay, but for that I will need omega 1 also. One more effort will be required. We cannot directly find the omega g. Okay, yeah. So 2 calculations will be required here. Little bit calculative it is. Okay, so first I will have to go to the AC. Okay, using AC I will first find omega 1. Using AC I will first find omega 1. So if I go to AC, see how much is the slope for AC? For AC the slope is initial slope only, minus 20. Change in magnitude, this is given. Okay, how much is this magnitude? This is 18. Okay, so change in magnitude 18 minus 32. Okay, divided by log omega 1 minus log of 0.1. Okay, so let me see how much is this answer turning out to be. This is 0.5. Just calculations you can do now. So this omega 1 is coming out to be 0.5. Okay, omega 1 is coming out to be 0.5. Now I will go to the CD. Now I go to the CD, the slope is minus 40. Change in magnitude 0 minus 18 divided by change in log of frequency, that is log of omega g minus log of omega 1. Okay, omega 1 is 0.5. Log of 0.5. Okay, so this was also indirectly required, omega 1, which I have calculated. Now (1.4) approximately. Omega g is approximately 1.4. Correct. So B is also correct. The B is also correct. It is sent in my Telegram group. It is sent in my Telegram group, Vishnu. Okay. Okay, dear. So the correct answer here is B also. And then we are left with C. Final phase. Okay. Final phase is a simple task only, because what is the final slope? It is given to be minimum phase. Na? Okay. Minimum phase system. The final slope is always, whether minimum or non-minimum phase actually, final slope is always minus 20 into P minus Z of the Bode plot, and which is shown here as minus 40. Okay, which is shown here as minus 40. So what is the value of P minus Z is 2. Okay, what is the value of P minus Z is equal to 2. Okay, now for a minimum phase system, final phase is given by minus 90 degree into P minus Z. So P minus Z is already obtained as 2, so minus 180 degree. So yes, final phase is minus 180 degree, so C also correct. A, B, C, all 3 correct. Okay, Joshna, just recheck. B is also getting to be correct only. A, B, C, 3 options are correct. Okay. Okay. Next question. The asymptotic Bode magnitude plot, another one, is shown. It is a type 2 system. It has 2 poles and it has 2 zeros and 3 poles. Final transfer function also they are asking, and there are 3 poles at the corner frequency omega equal to 10. Let's check it. Let's check it. Okay. First of all, it is definitely not a type 2 system. Okay. The asymptotic Bode magnitude plot for unity feedback system, let me be more specific in the question. For unity feedback system is shown. Now see, what is the initial slope? Okay, you talk about this portion, and what is the initial slope? The slope is 0 because the line is parallel to the x-axis. Initial slope 0. And if initial slope is 0, n equal to 0 pole at origin. There is no pole at origin or neither 0 at origin. There is no pole or no 0 at origin. Okay. Let me not only say pole, because initial slope positive means 0 is our origin. Initial slope 0, that means no poles or zeros at origin. So at origin there is nothing, no pole or 0. But there is no pole at 0 indicate type 0. So it is definitely not type 2. It is definitely not type 2. Okay, so this is wrong. Now what are my slope change points? What are my slope change points? This is the first point where slope will change. Okay, and slope becomes positive. Okay, a positive change of slope is due to a 0. Due to a single 0, slope changes by 20. Due to a single 0, slope changes by 20. But due to 2 zeros, slope change can occur by 40. The slope changes 40 decibel per decade. So we will have 2 zeros here. 2 zeros at what corner frequency? Okay, corner frequency will be 2. Okay, then how much is the slope change here? 40 to minus 20. See, slope change will matter. Okay, how much is the slope change here? Minus 60, minus 20, minus 40. 40, when you reduce by 60, then you get minus 20. The slope suddenly changes by minus 60. Slope suddenly changes by minus 60. That means there are 3 poles at the same corner frequency. What is this corner frequency? That is equal to 10. Okay, now for any term 1 plus st, okay, whether it is 1 plus st or 1 upon 1 plus st, okay, the corner frequency actually is given by reciprocal of time constant. Okay, so what is the time constant for the pole? The time constant 1 upon 10 or 0.1. Okay, and for the zeros, the time constant here is 1 upon omega c, 1 by 2 or 0.5. Okay, and there are no poles or zeros at origin. So how my transfer function should look like? They're asking the transfer function also. See, it has 2 zeros and 3 poles. Yes, as of now correct, because there are no poles at origin, no zeros at origin. So 2 zeros and 3 poles, this is correct. Okay, this is correct. And 3 poles at the corner frequency omega equal to 10, that is also correct. At omega equal to 10, 3 poles. Now the transfer function, okay, which is given in non-standard form, we can do that also. But finally, how, generally how will you express that transfer function? That transfer function generally can I express as k into some zeros terms. Okay. Okay, but I know that the 0 corner frequency and there is a repeated 0, 2 zeros divided by s power n, but s power 0, there is no pole or 0 at origin. So directly the pole term, okay, suppose 1 plus stn, 3 poles, so cube. Okay, then the values, what is the time constant? For zeros it is 0.5, or let me write it as 1 by 2 only. And this TA is 1 by 10. For the pole, the time constant is 1 by 10. Okay, what is unknown is k. So before k, we cannot write down the answer. Okay, before k, we cannot write down the answer. Avinash says k is 100. Okay, so let us see what is the k. Again, to find out k, okay, again, to find out the value of k, again go to the initial part formula. Na? What will be the initial magnitude here? Because n is 0, the initial magnitude is 20 log k. And initial magnitude is given as 40. 40 is 20 log k. So log k is 2 and k will be 10 raised to the power 2. So k is 100, correct? So I'll just substitute the value. My transfer function would be 100 1 plus s by 2 whole square divided by 1 plus s divided by 10 whole cube. Okay, they are given in the non-standard form, s plus a format, so no problem. 100. Now this s by s by 10. Okay, so this 10, actually 10 cube will jump to the numerator, and from here 2 square will come. Okay, then this term is s plus 2 whole square divided by the s plus 10 whole cube. Okay, so correct, 100 by 4, 25, and 10 power 3000. So correct answer 25,000 s plus 2 whole square upon s plus 10 whole cube. Okay, so option number C is also correct. B, C, D. 3 options are correct here. That is the B, C, D. That is the B, C, D. Telegram group link same as yesterday only. I'll share you once again the same Telegram group. I'll share you the today's PDF also, all this MSQ questions and with their solutions. Okay. Tell me a next one, PID controller, theoretical question mostly. Okay, just read an answer. I'll share you the Telegram link also. Just you have to read an answer here, nothing great. Okay. Let's move ahead to this question. PID controller. The derivative mode improves the transient performance or improves the steady state performance? The derivative mode will always improve the transient performance. Okay. So, when I talk about PID, okay, there are 3 proportional constant Kp, integral constant Ki, and the derivative constant Kd, which will increase the value of zeta. Okay, which will increase up the value of zeta, and because zeta increases, okay, it decreases the overshoot. Okay, we know that if zeta increase, overshoot will decrease, and it improves the transient performance by reducing the fluctuation. Integral part will always improve the steady state performance. It increases the type of the system, and hence the steady state error, okay, will reduce actually drastically, reduce significantly. Okay, it improves the steady state performance, A and D. Right. So these are, just one example. There are a lot of questions that can be on the direct conclusions with respect to, the controllers that can be discussed. A compensator has the transfer function GS given to you. A compensator has the transfer function GS. Okay. First of all, you have to identify whether it is the lead compensator or a lag compensator. Okay, and the maximum. See, this itself is a normal standalone question many times. Identify whether it is a lead or lag. Okay, so what about the pole and 0? Okay, so 0 will be at minus 1 upon 0.1, that is minus 10, and pole is at s equal to minus 1. Okay, so it is pole dominant or 0 dominant? Okay, it is pole dominant or 0 dominant? Okay, first the pole is coming and then 0. Okay, and pole dominant means lag function. Okay, pole is closer to the origin as compared to the 0. Pole dominant means it is a lag compensator. It is a lag compensator. Okay, not the lead one. It is a lag compensator, and then lag compensator you can also generally express by the transfer function 1 plus st upon 1 plus s beta t. So if you compare it, 1 plus st upon 1 plus s beta t, what is given to me is 1 plus 0.1 s divided by 1 plus s. Okay, so on comparison, okay, the time constant is 0.1. Okay, and then beta into t is 1. Okay, beta into 0.1 is 1. So what is the value of beta? 1 upon 0.1, beta equal to the 10. What is the value of beta? Beta will be equal to the 10. Right, beta will be 10. Now, what is the maximum phase lead? It occurs at which frequency? Okay, phase lag. It will be phase lag actually. Okay. So the formulas, these are 2 formulas producing questions normally from this. Maximum phase lag phi m is given by the formula of sine inverse 1 minus beta upon 1 plus beta. Okay. Sine inverse 1 plus minus beta upon 1 plus beta. Of course, take the magnitude if you are already calling it as a lag term. Okay, at which frequency? At omega m given by the formula 1 upon t root beta. 1 upon t root beta. Right now, they are only asking omega m. So, what is that omega m? For the current question, the omega m is 1 by t. What is the value of t? T was 0.1 into root 10. Okay. So, it's like 10 by root 10. Okay. So, 3.16. 3.16. Root 10 only, correct. This can be simplified as root 10 only. Okay. So, root 10. Option number D, correct. Okay, phi m they are not asking, but okay, if I just find out, so that will be given by sine inverse of 1 minus beta. And what is the value of beta? Beta is 10 upon 1 plus 10. Okay, and this is sine inverse 9 by 11. So this is 54.9 degree. 54.9 degree, correct? 54.9. So they have not asked that maximum phase. So it is a lag compensator, correct? The correct options are it is a lag and the maximum phase lead or lag occurs at root 10 radian per second. C and D are the correct answers here. C and D are the correct answers here. Even dear, if it is a lead, even if it is a lead compensator, see, always in the lag 1 plus st upon 1 plus s beta t, beta will be greater than 1. But the point is, if it is lead compensator also, these formulas will not change. Okay, if it is a phase lead, okay, phase lead. Okay, phase lead compensator is the one which has zero dominance. It has zero dominance. Its transfer function is represented, okay, in the similar format. Okay, 1 plus st divided by 1 plus s alpha t. Okay, but alpha will be less than 1. Okay, and the phi m formula dear is similar. Sine inverse 1 minus alpha upon 1 plus alpha. That will be known as the maximum phase lead provided by this compensator. And the value of omega m also same formula, 1 upon t root alpha. Okay, so the phi m and omega m is same. It's just one formula you have to remember for both of them. Okay, phase lead means zero dominance, or if you represent in this format 1 plus st upon 1 plus s alpha t, alpha less than 1. Lag means pole dominance, or if you represent in the standard form 1 plus st upon 1 plus s beta t, beta greater than 1. Okay. These are the formulas. Next, a GATE 24 2 marks MSQ question. A GATE 24 2 marks MSQ question from state space modeling. Okay. Consider a state system represented in the state space as. So, always, if you have followed any of my earlier classes, always I have been telling you the standard state space model, the canonical forms of the state space models are always very important. Okay. And is this any of the standard form? I'll tell you. Okay. When I talk about state space model, okay, the standard forms also known as the canonical forms are very important. 4 standard forms you will normally always remember, that is the CCF, OCF, DCF and JCF. Okay, the CCF and the DCF and the JCF are also referred to as the normal forms. These will only come under the parallel decomposition case. Okay, so if I take an example first. Okay, suppose you have the second order transfer function. Okay, starting with second order. If you have the second order transfer function, B C1s plus C0 divided by S square plus A1s plus A0. Okay, if this is some second order transfer function, okay, how do you represent the system in the CCF, the controllable canonical form? Okay, controllable canonical form. This, because such a form is always controllable. How do you represent this in the controllable canonical form? Okay, if you don't know the full forms, you can write down CCF, controllable canonical form. X dot, okay, is given by AX plus BU, Y equal to CX. Okay, now what is the A matrix in the CCF? The first row will be fixed as 0, 1. The first row is fixed as 0, 1. I'm not deriving, I'm giving you the final results. And the second row, important, is formed from the denominator. So go to the denominator of the transfer function and take the constant. The constant term is A0 and write it in the opposite sign, minus A0, and then go to the next term, minus A1. Okay, the B matrix, first element 0, second, if there is any common term in the numerator, B is written here. Y equal to, okay, Y is equal to C0 C1. Now, you know why? Start with the constant of the numerator now. What is numerator constant? C0, and then go reverse C1, same sign. Okay, same sign, C0 and C1. That is the C0 and the C1, correct? Now, if you want to write down the OCF model for this, okay, see, only CCF you have to remember. OCF is going to come up by default. How? What you are required to do is, let me just write down the structure first. We know that X dot is AX plus BU, Y equal to CX. What you are required to remember, dear, here is, if it is OCF format, whatever is the A matrix, take the transpose, okay, and write down in the OCF format. Okay, so when I take the transpose, the first row becomes first column 0, 1. And second row becomes second column, minus A0, minus A1. Minus A0, minus A1. Then, whatever was the B matrix, take the transpose and write in place of C. Write in place of the C. So, 0B is a column that gets converted to the row. That is 0B. Okay. And whatever was the C matrix, take the transpose of C and write in place of B. Write in place of B. So, C0, C1 was the row, converted to the column C0, C1. Converted to the column C0, C1. Okay. Converted to the column C0, C1. Okay. Okay. Now, if it is not in any of the standard form, then what is the transfer function? That also I'll explain to you. Okay. Now, next term. Okay. Now, if you have to write this in the DCF form, if you have to write down the same in the DCF form, keep listening. Okay, so for DCM form, you have to first factorize it. Okay, denominator, suppose it is factorizable as S plus P1, S plus P2, assuming it has two poles, and then you have to split this into the partial fraction. K upon S plus P1, some K2 upon S plus P2. Partial fraction is applied. So that means what are the poles of the systems? Minus P1 minus P2, assuming both distinct. DCF will only come when the poles are distinct. DCF will only come when the poles are distinct. Okay. So, what is the DCF model? The DCF model is representable as X dot is equal to AX plus BU, Y is equal to CX. Now, what is the A matrix? Okay, A matrix will be a diagonal matrix containing the poles. Okay, containing the poles. Diagonal elements are the poles, minus P1, minus P2, rest are 0. Okay, what is B and C matrix? B and C matrix, suppose the elements in B is B1, B2. The elements in C is C1, C2. What are this B1, B2, C1, C2? Okay, the B1 and C1 should be K1. What is B1, C1? Choose B1, C1 so that the product of B1, C1 is K1, the first partial fraction number. And similarly, B2 into C2 should satisfy K2. This is how we get the DCF form. This is how we get the DCF form. Clear? Right. Now, from the state space model, okay, from the state space model, what is the transfer function? From the state space model, what is the transfer function? So see, this was looking like, let me be very clear, this was looking like, okay, 0, 1, it may be OCF format, but it is not strictly OCF format, because for OCF, what I need? Okay, the C matrix here should be 0B format. Okay, C0, C1 and 0B format. Okay, the 0, 1 format, which is not available here. Okay, which is not available here. Okay, so if it is not in any of the standard form, then how do you write down the transfer function? Okay, Rupesh, for Gilbert's test, very recently I have taken a complete video, only alone on Gilbert's test. Kalman separate video, Gilbert separate video, you can watch it, a detailed explanation is there. So dear, okay, so if I, if it is any non-standard form, if any random form is given, whether standard or non-standard, general formula. So see, if any standard form given, okay, question, suppose you want transfer function, write down the transfer function, okay, by the above techniques that I have told you. Okay, direct techniques. Okay. If it is any non-standard form, any random form given, if any random form is given, if any non-standard random form is given, okay, how do you write down the transfer function? The transfer function is then given by the formula C phi s into B plus D. C into phi s into the B plus D. C into the phi s into B plus D. Okay, now what is phi s? What is phi s? Phi s is a term known as the Laplace transform of phi t. Okay, where phi t is the state transition matrix. Phi t is known as the state transition matrix. Okay, phi t state transition matrix given by the formula e power at. Okay, now what is this phi s equal to? This phi s is given by the si minus a whole inverse. Right now I only need phi s, but if they ask you phi t state transition matrix, then of course, okay, phi s is the Laplace of phi t. So phi t is the inverse Laplace of phi s. That is inverse Laplace of si minus a whole inverse. Okay, we will do these calculations now. Okay, so what I first need is phi s. Okay, that is si minus a whole inverse. So what is the transfer function? That we are going to check now. Right? So what is the transfer function? Okay, first of all, I need si minus a. Okay, so S into I, identity matrix. And what is the A of the question? What is the A matrix of the question? Okay, that I will copy here, right? What is the A matrix of the question? What is the A matrix of the question? 0, minus 2, 1 and minus 3. 0, minus 2, 1 and minus 3. Okay, so this becomes how much? S into 1 minus 0, S. Then second term 0 minus 2, that is plus 2. 0 minus 1 and last is S and minus S plus 3. Okay. So what is Si minus a whole inverse? Next term. What is the Si minus a whole inverse? The Si minus a whole inverse is given by what formula? The Si minus a inverse is given by the inverse of any matrix, adjoint divided by determinant. Inverse of any matrix is adjoint divided by the determinant. So what is the adjoint of this matrix? For a 2 cross 2 matrix, just change the diagonal numbers, exchange the diagonal numbers, and for off diagonal numbers, change the sign. 2 will become minus 2, minus 1 will become plus 1. That is the adjoint of the matrix. Determinant, I will again cross multiply S plus 3, minus plus 2. Okay, so what is the final phi s term? What is phi s for me? As I told you, Si minus a whole inverse, and that Si minus a whole inverse, okay, is S plus 3 minus 2, 1 and S whole divided by, let this term be separate only, we'll divide later if required, S square plus 3S plus 2. Now what is the transfer function of the system? Now the transfer function is C phi B plus D. There is no D matrix given in the question. Okay, so transfer function is C into phi into B plus D. Okay, D is not given. Now let us write down the C and B matrix. What is the C matrix of the given question? Okay, C matrix 2 and minus 5. Okay, and the B matrix is 1, 0. Let me write down both of them. C is 2 and minus 5. 2 and minus 5. okay, into the phi S matrix, which I will copy once again, divided by the B matrix, which is 1, 0, and D is not given. Now, what is the phi matrix? S plus 3, S here, minus 2 and plus 1 here, and whole divided by the S square plus 3S plus 2. Now, what are you going to multiply first? Okay, what are you going to multiply first? Right. Okay. Yeah. So you can multiply any of them actually, but if you multiply phi into B, it is easier because there is one element 0. So try to make the calculation simpler in the beginning only. So 2 and minus 5. Then see S plus 3 into 1 and the second is 0. So only S plus 3. Second row 1 into 1 and then 0. So only 1. So yeah, calculation starts simple from the beginning only. Whole divide by S square plus 3S plus 2. Now this one row and one column multiplied. So the final transfer function, this alone is a question. Find the transfer function. So that becomes twice of S plus 3. Okay. Minus 5 upon S square plus 3S plus 2. Okay. So 2S. Okay. Plus 6 minus 1. So 2S plus 1 upon, can we factorize it? Okay. Let me first write it like this. S square plus 3S plus 2. Okay. S square plus 3S plus 2. 2S plus 1 upon S square plus 3S plus 2. Correct. Okay, 2S plus 1 upon, so what is my transfer function? See, my transfer function is now 2S plus 1 upon S square plus 3S plus 2. First of all, can I write down the CCF answer for this, and let's see if any answer matches by CCF. If I have to write down the CCF answer for this, see, 0, 1 minus A0 minus A1 into X. 0 into BU, there is no common. Okay, we can write this as 1 into 2S plus 1. So this is what becomes the B for me. This will be C0 C1. Okay, this is A0, this is A1. Correct. So minus A0 minus A1 will come up here, and Y equal to CX. C is C0 C1. C0 means the constant and then C1. Okay, so this is one possible state space model. Okay, this is one possibility of state space model. Okay. Okay. Yes, Avinash. Observable if, if you express it in CCF, see, if you express in CCF, it is always controllable, and if then though no pole zero cancellation, then observable. Okay. Chalo, next. So, do you have any such option? Okay. So, this is what is corresponding to my CCF answer. Same thing I have written. 1 and 2 I have got. I have got 1 and 2 only. 0, 1, minus 2, minus 3. I'll show you once again. Correct. 1 and 2. Yeah. So at least B part is correct. At least the B option is definitely correct. Okay. At least B is definitely correct. Okay. Now A and C. Now, how will I say whether A and C is right or wrong? Okay. A and C. Okay. Both the matrices in A and C are only diagonal matrices containing the poles. I'll show you the poles. Containing only the poles. Okay. Containing only the poles. Right. Containing only the poles. Clear? So A and C are diagonal form. A and C are related to the diagonal form. Okay, A and C are related to the diagonal form. Now this is also CCF form, but this element will not match. So D is wrong. D is wrong definitely. Okay, D is definitely going to be wrong. So let us come to the option number A or C by the DCF model. For DCF, I told you have to factorize it. Okay, let me factorize it. No, standard forms are only written, Sajin, I have told you, for strictly proper transfer functions. Okay, degree of numerator less than degree of denominator. Correct. Otherwise, general formula C phi B plus D. Okay, or otherwise decomposition if you want to have the state space model. Now, okay, now, dear, if I break this transfer function, next condition, if I break this transfer function into the partial fraction, 2s plus 1 upon factorizable. S square plus 3s plus 2 is factorizable. S plus 1 and s plus 2. Okay, s plus 1 and s plus 2. So it should be equal to how much? Okay, some constant k1 upon s plus 1, some constant k2 upon s plus 2. So when you multiply s plus 1, s plus 2 throughout, what are the constants going to come? 2s plus 1, k1 s plus 2, k2 s plus 1. Quickly solving the partial fraction. Let me first put s equal to minus 1. So 2 into minus 1, minus 2 plus 1 is equal to k1 into 1. K2 part will be 0. So k1 is minus 1. And if I put s equal to minus 2, so minus 4 plus 1, k1 part will be now 0 and k2 into minus 2 plus 1. So k2 part is equal to the plus 3. Okay, so what is my transfer function? Okay, k1 minus 1 upon s plus 1 and plus 3 upon s plus 2. Okay, plus 3 upon s plus 2. Okay, so what is my DCF model? X dot equal to AX, diagonal matrix containing only the poles. Minus 1, minus 2, these are the poles. X dot is AX plus BU. Okay, BU. Okay, and Y equal to CX. Okay, now dear, here I told you the elements are suppose B1, C1. The B1, C1 should be equal to minus 1. The B1, C1 should be equal to minus 1. Okay, so you can choose 1 and minus 1. You can choose 1 and minus 1. Right. 1 and minus 1 means I will see which one to be chosen. Okay, I will see which one to be chosen. Okay, as per the options I will decide. Na? The product of these two should be 1 and minus 1. The product of these two should be 1 and minus 1. Okay, 1 and minus 1. Yes, yes. So here I'll choose minus 1, here I'll choose 1. Okay, and then next is 3 into 1. Next automatically matches. Okay, so this is what I'm going to use here. Right, dear? Yes. So, what was that calculation? B1 C1 is equal to K1, which is minus 1. So, let us choose as per the options. I will place as minus 1 and 1. So, B1 is minus 1 and this is 1. Okay, and then the next calculation, B2 into C2 in the DCA form should be K2. K2 is 3. Okay, so we are choosing it as 1 and 3. Oh, again, I forgot whether it was 1 and 3. 1 and 3 and 3 and 1. Anything I can choose. Anything I can choose. So I am choosing it as 3 and 1 as per the options given to me. Okay, let's choose 3 and 1. So let me put this as 3 and let me put this as 1. Let me put this as 1. Correct. So then which option clearly matches? Which option clearly matches? Option number C. So B and C are the correct answer, dear, for this particular question. B and C are the correct answer for this particular question. With this, I have, quickly revised 3 important state space forms for you. Okay, standard state space form for you. Okay, and they are respectively, okay, CCF, OCF and DCF. JCF, we need repeated poles. So that was not there in this question. So that is why we cannot talk about the JCF 100%. We cannot talk about the JCF for sure 100%. Okay. DCF also, please remember, in the DCF, okay, matrix A is always a diagonal matrix. That is why we name it as diagonal canonical form. Matrix A is a diagonal matrix, okay, with non-repeated. I told you, both the poles should be distinct, non-repeated, with non-repeated poles or with non-repeated eigenvalues. Non-repeated eigenvalues. Okay. 1 or 2 more points I will add. Okay, so normally state space model, whether it is OCF or DCF or JCF, anything, the general way of writing the state space model is x dot equal to AX plus BU, Y equal to the CX plus DU. Y equal to the CX plus DU. Okay, so what is the characteristic equation of matrix A? Characteristic equation of the matrix A, that we learn in the linear algebra. Okay, and that is given by determinant of A minus lambda I equal to the 0. Okay, and the roots of the characteristic equation are known as lambda, which are eigenvalues. which are eigenvalues. Okay, then the characteristic equation of matrix is always identical to the characteristic equation of the system, of the control system. So we write down the characteristic equation of control system also as modulus of A minus SI, or rather, standard form you will see like this. Anything, both are equivalent only. Determinant of SI minus A equal to the 0. Okay, and the roots of the characteristic equation of control system are the poles of the system. Okay, we know this. Roots of characteristic equation represent the poles of the system. Represent the poles of the system. Okay, that means the poles and eigenvalues are also same. The poles of system is equal to the eigenvalues of the matrix A. Eigenvalues of the matrix A. Okay. One more important formula that we revised from here is the state transition matrix. Alone expect questions from this. Alone you can expect the question. Okay. The first calculation is 5s only, SI minus A whole inverse, like we have done here. After that, of course, inverse Laplace technique you have to apply, and all those things. Okay. All those things will have to be done. Okay. Have a look into this next question. Again, a MSQ question. X1 dot is x2 and x2 dot is minus 2. First, let me write this in the matrix form actually. Okay, in the matrix form, what is x1 dot x2 dot equal to? X1 dot x2 dot is equal to, so see, ax plus bu, y equal to the cx. Now, the first equation only has x2, no x1 and no input also, so 0 into u. Second equation, minus 2x1 minus x2 and plus u, and y depends only on x1. So see dear, what type of form is actually given in this question? 0, 1 minus a0 minus a1. Okay, 0, 1 minus a0 minus a1. By looking into this, I am able to say that yes, it is a CCF model. Okay, it is a CCF model. Okay, now the option is, you don't have to apply any Kalman's test. Okay, controllability and observability. It is controllable. CCF is always controllable. CCF form is controllable. It is the pure CCF form. 0, 1 minus a0 minus a1 plus 0 bu and y equal to c0 c1x. Okay, it is so controllable. That is where the form, this model gets the name controllable canonical form. If a question is an OCF, it will always be observable because that is known as observable canonical form. Right? So it is going to be controllable, okay, for sure. Otherwise, you have to check by Kalman's test, which is not required here. Okay, now tell me the transfer function. Shortcut for observability of CCF form. What is the transfer function? How do we write transfer function? Reverse application. So B. See, previously, just in the previous question, I told you, transfer function I have calculated by the formula C5B because it was not a standard form. What I also told you, whenever any standard form is given, write down the transfer function by the tricks of CCF, OCF, DCF. If non-standard form, then only use this. This is the general formula actually. This is the general formula. You can use it for any question. But if it is standard form, this will spend your time. Now write down by the tricks directly. So what is my transfer function? See here. What is my transfer function? 1 into, now what is C0? C0 means the constant of numerator. C1 is coefficient of S reverse, so 0 into S divided by, now, minus A0 minus A1. A0 means the constant, okay, plus 1 into S, plus S square. Okay, so what is my transfer function? 1 upon S square plus S plus 2. 1 upon S square plus S plus 2. Now, when the question is in CCF form and if there is no pole zero cancellation, it is observable. Is there any pole zero cancellation? There is no zero only, na? If there was a 0, then we think whether it can be cancelled with a pole or not. Okay, so there is no pole zero cancellation. Okay, so observable also. If the system is in CCF form, it is always controllable, and if there is no pole zero cancellation, it will be observable also. For both of them, you can skip the Kalman's test. Okay, where to apply Karmals, where you can skip. Where to apply Gilbert's, that is only for normal form. Okay, I told you yesterday also, for that, if you want the complete details of controllability, observability, 100% all types of cases, you can watch my video just 1 or 2 weeks back. I have taken 2 weeks back probably. Okay, controllability and observability, 2 videos, one for Kalman separately, one for the Gilbert separately. Okay, so it is observable also, be correct. Okay, now minimum phase or stability, instability. Okay, suppose this is alone a question. Okay, what you have to do? No need to write down the entire transfer function. Here I have written, okay, but if the question is only on stability or minimum, non-minimum phase, you can directly calculate the poles by the eigenvalues. Okay, so you can directly try to calculate the eigenvalues of the matrix here. But right now, since transfer function effort is done, okay, s square plus s plus 2 equal to 0. If I solve from here, I'll be getting -1 plus minus root over b square minus 4ac divided by 2a. Okay, so it is -1 plus minus j root 7, under root of -7, na? Yeah, so j root 7, pure imaginary, complex conjugate. Okay, but the real part is negative. That means both in LHP. Both in LHP. The system is stable. Okay, this is wrong. Both LHP, system is stable. And anyway, second order, na, you can say by the zeta also. Zeta is positive. It is stable. It is purely stable only, Avinash. Okay, this is the final transfer function. Now next, okay, is it minimum phase? What is minimum phase? All poles and zeros in LHP. There are no zeros, only poles, but yes, whether both the poles are in LHP, yes. So it is minimum phase also. So ABD is the correct answer for the question. ABD is the correct answer for the question. ABD is the correct answer for this particular question. Clear? Is the correct answer for this particular question. All right. All right, guys. So yeah, that's it. That's it for this class. And as you know, mega marathons have started. Yesterday we had the non-stop 8.5 hours control system marathon, and now again a reminder for tomorrow. Okay, again a reminder for tomorrow. Be ready at 11 a.m. Okay, be ready at 11 a.m. Okay, for ECEI and all of you, electromagnetic fields. Okay, the common syllabus of electromagnetics. Okay, and then sir will plan the core EC part. Right. Yeah, that is the closed loop transfer function, just little info, correct. Okay, so EMF tomorrow at 11 a.m. I shall share you the link of the EMF session also, so that you can attend, directly using that link. Yes, this is the link of EMF session. Okay, set a reminder for it. Save the link for you. Set a reminder. Or anyways, in case if you are subscribed, you will already be notified about all the events. Okay, about all the events. Analog will be taken by Gautam sir. Password for today's PDF. Good reminder, Venkat. Okay, so as you know, today's PDF I'll share you. Let the password for today's PDF be DCF. I told randomly whatever clicks to my mind. So, DCF is going to be the password for today's PDF. The complete MSQ questions with the discussions, with the solutions. Okay. The password will be DCF, everything in small. Everything in small. Yesterday's control system complete marathon PDF was there in my Telegram group. Right. This also I'll share you mostly by night only. Okay. In the same Telegram group. Right. Tomorrow, be ready for this next mega marathon on EMF by Hemant sir. The timing will be 11 a.m. Link for EMF I have shared with you. Okay. Link for EMF I have shared with you. Right, guys. And the big announcement is the first offline batch. Okay, for GATE 2026, ENEC both, the first offline batch starts from February 24th. The fee is currently priced as 54,999, but if you register till 30th of Jan, you can avail additional 4,000 discounts. So you can pass on to this information, okay, to your friends and juniors as well. And for those who want to study in the online mode, they can't travel, by chance for offline. So you can have the online live courses also. And the first GATE 26-27 online live course starts from February 8th. 1 year fee 99.99, 2 year fee 28,999, and again if you enroll till 30th of January, a flat 25% discount. And also, as I mentioned, for the online courses of OM, the scholarship test is anyways there. So if you want, better, scholarships, better discounts, so you have to just prove yourself, earn your respect, earn your discount. Top 3 will get 100% scholarship, and based on your performance, different scholarship. This scholarship test, as I already mentioned in the beginning also, 19th of January, that is coming Sunday, 6:30 p.m. This is going to be live. Okay, and for the AE offline courses, okay, the next AE offline batch, okay, for Telangana, Transco and Discoms exam, as well as for AP Transco and Discoms, the next offline batch starts 23rd of January. Okay, for details, you can again coordinate with the number 9515694053. Okay, that's it from my end. Thank you. Stay safe, take care, keep learning, and enjoy the tomorrow's EMF marathon. Okay.